Hey everyone, this is Zach speaking on behalf of Group 1. Group 1 is made of Kristen, Marina, Nermeen, Jean-Carlos, and myself. I'm sure they'll introduce themselves later. Our self-design experiment follows the previous experiments we did in this class with concrete. We just did a slight modification with a sugar admixture. So first I'll fill you in on the inspiration for this experiment. One day I was scrolling down Instagram and I came across this post. This post explains that French abolitionists mixed bags of sugar into concrete with the intention of sabotaging the successful construction of new prisons in the 1980s. As the claim goes, 2 pounds of sugar can ruin a literal ton of concrete, making it unable to set properly. Putting historical context aside, that brings us to our hypothesis. We can test the question, does regular table sugar dramatically decrease the strength and durability of concrete, even in extremely small concentrations? Some scientific background. Sucrose is a retarding agent to concrete due to its covalent interaction with calcium carbonate. It can delay the setting time, and in high enough quantities, it can permanently decrease the prospective strength characteristics, like compressive strength, which we will be testing. The first part of this experiment is just following the ACI 211 procedure that we did in the first class. So that's for creating a proper Portland cement concrete or PCC mix design. The steps we follow are exactly the same as laid out in the ACI manual. However, we modified it to test several cylinder samples with varying concentrations of table sugar, sucrose, mixed in. A total of 14 cylinders were made from one batch of concrete. There were 7 different concrete mix compositions among those cylinders, making 2 of each type. There were 12 cylinders containing 6 varying concentrations of sugar mixed into the concrete batch. 2 additional cylinders of concrete with no sugar added were produced as a control specimen. So that's going to be the one that displays the highest strength, and those actually came out pretty good, as my group members will explain shortly. So we do the control because we want to know how strong the concrete is on its own without the sugar. So here's some pictures that I took. So you could see the one all the way on the left has no sugar, so that's the control. And then with each incremental one going to the right, you could see there's like more and more moisture content. The pure concrete was mixed in one large batch, and appropriate amounts of sugar were weighed and added to the cylinders individually. Separate portions of the original mixture were taken and added to buckets in the amount approximately equal to 2 test cylinders worth for each concentration. We had a little bit left over. So preceding the modified mix design, we conducted the 7 and 14-day compressive strength tests as laid out by the C39/C30M20 standard. So just 7 and 14-day tests. We couldn't do the 28-day test because we didn't have enough time. I also want to touch on the bucket rolling technique that we used to mix it. So our first concrete mixture came out really poor on the first day of class because we just kind of mixed it with our hand using the scoop, and that probably wasn't the most efficient. So what we did this time was we put it into buckets and we rolled the bucket across the room, and that kind of replicated a mixing truck, and it was a really good mix. So our cylinders came out really good this time. And here's a picture of one of the, I think this is like the 2% that was crushed. So here you can see I'm holding up after they were tested and they failed. The one on the right is no sugar. The one on the left, I think that's the 4%. And then Kristen's holding, I think, the 4% after it. No, that would be like the 2%. But yeah, so you can see how the sugar had a drastic effect. So anyway, with that, I'll hand it off to my colleagues to continue the presentation. Thank you.